So now let's talk about what a closed form is. So definition. If a sum with a variable number of terms is shown to equal an expression that does not contain an ellipsis, which is the ... or a summation symbol, we say the sum is written in closed form. So we already saw an example of this in our previous problem where we were proving something by induction. We had this formula here, 1 plus 2 plus up through k equals k plus 1 over 2. So if you look over here on this right-hand side, there's no summation symbol, there's no ... So this would be a closed form. So let's try to express some summations in closed form. Okay. Let's evaluate 2 plus 4 plus 6 all the way up to 500. Now, I do not want you to compute this by hand. I don't want you to take out a calculator and add the even numbers from 2 to 500 up. It would take way too long. So what we're going to do instead is we're going to manipulate this a little bit. All these numbers are even, so I can factor a 2 out of them. And then look at what I'm left with. The sum of 1 up through 250. So for this part right here, we can use this formula to help us out, where k is replaced by 250. So this would be 2 times 250 times 251 divided by 2. So the 2's would cancel now, and the sum would equal 62,750. All right, so let's do something a little bit different. Let's evaluate 5 plus 6 plus 7 plus 8 all the way up to 50. So I'm going to take this, and again I want to use my formula to help me out here, but I'm missing some terms. Which terms am I missing? I'm missing the numbers 1 up through 4. So let's add them in and then subtract them away. Plus 4. And now I can use, I haven't changed anything because the 1, 2, 3, and 4 cancel. In the front, they're positive, and in the back, they're negative. And then I can use, again, my formula for this part right here. It would be k is 50. 50 times 51 over 2 minus 10. So this would be 25 times 51 minus 10 or 1265. So you can use that formula that we proved on that last induction to help you simplify these terms here and write them in enclosed form. So let's talk about a geometric sequence now. A geometric sequence is a sequence where each term is obtained from the preceding one by multiplying by a constant factor. So, an example of this, let's say my sequence starts with the number 1 and my constant factor is r, so I multiply 1 by r to get r, multiply by r again to get r squared, r cubed, and in general it would be r to the n. So this is an example of a geometric sequence. The first term is 1 and my constant factor is r. So then what I can do is I can take this sequence and I can add some of the terms together to get a nice summation formula. So then we have the following sum formula for n greater than or equal to 1. If I add 1 plus r squared all the way up to r to the n, it's equal to r to the n plus 1 minus 1 over r minus 1.